Hello everyone. It's my honor to share my research here. The title of my research is Dynamic Differentiation Approach for Adversarial Robustness in Deep Neural Network via Stochastic Ensembles Most Models. So my speech will be divided into those four parts. Let's begin from the first part, introductions. Deep learning has been widely used in the problem of image recognition, such as the ImageNet classifications, object detections, and autopilot, even the face identifiers problems. While this technology brings convenience to people's deep neural network have been shown to suffer from the critical vulnerabilities under the adversarial attacks. So these phenomena stimulate the creations of the different attack and defense strategies. So the dependence of such strategies on attack and defense mechanisms makes the associated algorithms on both sides appear as a closely reciprocating process. This reciprocating process became the endless arms race with the widespread use of the empirical defenses method. For instance, the model ensembles and model distillations, even the input transformations, has been proposed successfully as defensive method and later studied as a means of improving attack capabilities. So on the contrary, the improvement of the attacking performance is improved by the defensive side in the way of adversarial trainings. So on the other hand, the certified defensive methods are supported by the rigorous theoretical security guarantees. Those methods overcome the shortcoming of the empirical defensive method, so the exacted of the conservative approaches. All those methods can't find a balance between the scalabilities for large data or the regularness guarantees. Besides the empirical defensive method, the certified defensive approach have the definite limitations. So following the theoretical development of the cyberspace securities, the two sides between the attack and defenses in a competitive game with no strongly security defenses method will eventually reach a Nash equilibrium. In order to maximize the result of the equilibrium, cyberspace defenses propose the methods such as moving target defenses and the thematic defenses models to achieve a generalized robust control method. So in our work, we adopt the dynamic defenses model ideologies in deep neural networks and propose an attribute-based stochastic ensemble models. To great extent, we hope to change the fix the correspondence between the input and output on the gradient intuitively. Uh, the unpredictabilities of the gradient makes it impossible for attackers to directly implement the white box attack, and the inefficient universality of the adversarial symbols makes the attacker helpless. So the attribute-based stochastic ensemble models have the characteristic of the diversity and the randomness and even the dynamics. So the second part, we will introduce our method in details. So in our method, a heterogeneous redundant model conclusions is introduced as an essential and novel part of method, making our model have the characteristics of randomness and diversities. Different model architectures and smoothing parameters is effective in expanding the diversity and the redundancies of the model conclusions. The table shows the model conclusion results used in these papers, and the auxiliary 7 models contrasted the whole model libraries used in the second part. So based on the model conclusions, this method takes the model orders, network architectures, and the smoothing parameters as the changeable attributes of the ensembles. When the stochastic ensemble model is recorded multiple times for gradient or output informations, the ensemble is achieved through a completely stochastic choices of the model quantities, network architectures, and smoothing parameters in each echoes. The reload of the ensemble with variable attributes before every requested make the model have the characteristics of the dynamic. So the second part, we will introduce our experiment and results. Different from the traditional attackers, the degrees of the knowledgeable of the model conclusions and the ensemble attributes determines attackers' capabilities. So we define the attackers' capabilities in a top-down fashions from A to D and baseline models from F to I, which is different from the traditional method. Because of the randomness of the ensemble and the input images, the Monte Carlo simulations is used for approximate evolutions in the same fashions. The abstention threshold is proposed to bound the acceptable probabilities of empirical risk. So this is our result of our experiment under the different attacker capabilities, attack method, attack targets, and the disturbance constraints. The robustness of the proposed method is fully characterized. For the result, we can get the conclusion that even the attacker with the highest attack capabilities cannot easily exceed the attack success rate associated with the ensemble's most models. So the last part, we will introduce our conclusions with our method. Uh, so in summary, the proposed method has the characteristics of the diversity, randomness, and the thematic to achieve the probabilistic attribute thematic definitions for adversarial robustness. In order to further improve the robustness under the white box attack, the frequency of the ensemble changes can be adaptively controlled by attack iterations for further works. Thank you for listening. If you have any problems, please contact me.